record. And Thomas uses number 12. Definitely, we'll get to number 12, and then I will go and start on 5.3 after those two problems, Carlos, so we can get that stuff taken care of. So guys, what I'm going to do, I'm going to use my calculator here, and what I'm going to do, remember my calculator that I'm using here, it's like the actual TI, but if I'm doing this on my calculator app, it's going to work exactly the same way. Okay. So what I'm going to do, I'm going to stop sharing. I mean, I want y'all, if y'all can look at the problem, or at least, jot these numbers down, or at least think about these numbers for a second. You don't have to necessarily memorize them. But what I want to show you, what I'm going to do is I'm going to use my calculator to do this problem right here. So let me stop sharing this piece here, and let me share my calculator with you guys. And just, let's see. Make sure that, yeah, you guys can see that. Okay, so guys, what I'm going to do is I'm going to come to my calculator. I'm going to go to second and stat. Oops, I'm sorry. Let me exit out of there. I don't want to go to second stat. I'm just going to go to stat. Here we go. And I'm going to go to edit. So I'm going to edit my list. My lists are clear right now, so I don't have anything in there, so I don't have to clear them out. What I'm going to do is the problem that we were talking about the number of dogs, and then we had probability. So for my number of dogs, the numbers that I had were 0, 1, 2, 3, 4, and 5. Okay, and then I'm going to go ahead and go to my second list, and I'm going to type in the numbers that I had for my probabilities. So the first number I had was a 0.683, and then I had a 0.199, and then I had a 0.077, and a 0.020, and a 0.012, and a 0.008. Okay, so now what I'm going to do is I'm going to come back to my calculator. I'm going to hit stat again, and I'm going to go ahead and go to calculate, and I'm going to calculate my one variable stats. And guys, I want to say that when I'm doing this on my calculator, on my calculator app, I'm going to have to open up parentheses, and I'm going to put list 1, comma, list 2. So I'm going to go second, list 1, and then comma, second, list 2. And if you have a newer calculator, let me see, I had one around here somewhere. But if you have like a TI-84, and I don't know if you guys can see me or not, but if I have this kind of a calculator, sometimes the first one says, let me see if this calculator does it. Calculate non-variable stats. Yeah, okay. So on this calculator, it says something like list, and then the second one says frequency list. So I would do L1 for my list, and then L2 for my frequency list, and then I'll hit calculate, okay? So if you have a calculator that looks like this, and you see that kind of a display, that's what you're gonna do. Anyway, I'm gonna go ahead and hit enter here. And so the first part is asking me for the mean of my distribution, okay? So I'm gonna write this down on a piece of paper just so that I can do this, and I'll come back to the problem and show you what I'm trying to write. So my X bar in this case here is my mean, and I'm coming up with 0.5015. That's what I'm coming up with, okay? And then the other thing I'm going to write down is I'm going to write down that sigma, the 0x. I'm coming up with a 0.91. So my sigma x is a 0.91. Okay, so let me stop sharing this screen with you guys, and then let me share the problem again. Okay, so you guys can see this. Okay, so right here, it's asking me to find the mean. So on my calculator, it was using X bar. X bar is still my mean, and it's asking me just around to 1 decimal place. So originally I wrote down 0.5015. I'm just gonna write 0.5 because it's asking me just to 1 decimal place. I will check my answer. Awesome. Now the second thing is asking me for the variance. So if you remember on my calculator, it had the little sigma with the X, and I came up with 0.91, and it's asking me to 1 decimal place. So what I'm going to do, guys, is I'm just going to take 0.91 and I'm going to square that, because if you notice, this is sigma being squared. So if I take my calculator, I'm going to do that real quick like here. Let me get my calculator app going on the phone. 0.91, and I square it. I'm coming up with something like 0.8281. And again, I'm just using my graph and calc thing here on my phone. And since I'm going to go with one decimal place, I'm just going to put 0.8. There we go. And then now it's asking me for my standard deviation. Again, it's asking me for one decimal place. And on that calculator, I came up with a 0.91. So I'm just going to write 0.9. I'm going to check my answer. And okay, now it's asking me, how would I interpret the results in the context of a real life situation? Okay, so one thing I want to mention here, remember the mu is my average, right? And the standard deviation is 0.9. So my average is a 0.5 and my standard deviation is a 0.9. So I'm going to look for the one that says the average is 0.5 with my standard deviation being a 0.9. And I think looks like it's going to be choice B, average of 0.5 with a standard deviation of 0.9. I'm going to chickadee check, and we got it. Let's see. Catherine, you were asking me about number 11. I don't know if that makes sense on how I did number 11, or at least the process and how I walked through it. But I hope it does. If excellent, great, perfect. So guys, let me go ahead, and I know Thomas had number 12, so let me go ahead and do number 12. Okay, so let's take a look at number 12, and it says the random variable x represents the number of cars per household in a town of 1,000. Find the probability of selecting a household that has less than 2 cars. Okay, so I'm gonna stop sharing this screen with you guys right here, and I'm gonna actually just share my like dry erase here. And it says find the probability that we have less than 2 cars. Okay, so if I think about the term less than 2 cars, what that means is we're either going to have no cars or we're going to have 1 car. Okay, so the probability of having no cars plus the probability of having 1 car. So when I do that and I come back to my problem here and I say, let's take a look. So here is 0 cars, here is 1 car. What I need to do is I need to come up with my probability distribution, because right now what I have is I have the number of cars or the number of households that have either no cars, 1 car, 2, 3, or 4, but I don't know necessarily the probability at this point. So what I'm going to do is I'm going to write something down on a piece of paper, and I'm going to get a pen because that one is gone. And I have 125 and 428 and 256 and 108 and 83. Okay, so guys, one thing I want to mention here is that the problem tells me this is the number of cars per household in a town of 1,000 households. So what that tells me is if I were to take the number 125, 428, 256, 108, and 83, if I add those numbers up, it should add up to 1,000. Okay. So what I'm going to do is I'm going to find the probability by taking these numbers 125, 428, 256, 108, and 83. I'm going to divide each of those numbers by 1,000, and I'm going to write my answer as a decimal. Okay. So if you give me 1 second, okay. If you give me a second, what I'm going to do is I'm going to take 125 and divide it by 1,000. And so for the first one, I'm coming up with 0.125. 428 divided by 1,000 should just be 0.428. Okay, so this is going to be easy breezy cover girl. 0.256, 0.108, and 0.083. Okay, so let me show you what I'm going to do here. Let me get out of this piece and oops. Come back here. Okay, so what I'm trying to do here, guys, is here's my x, and here's the probability of my x. So we had 0, 1, 2, 3, and 4. And when I took each of those numbers and divided them by 1,000, these were the numbers that we came up with, that I came up with. So when it's asking me to find the probability that I have less than 2 cars, I'm just going to take this number here and this number here and add them together. So if I take on my calculator 0.125 plus 0.428, I'm coming up with 0.553, and that should be my answer. So when I come back to my particular problem, the answer I'm looking for is 0.553, and let's see, that's going to be my choice A, and I'm just going to hit check my answer, and I'm done, right? And again, one thing I wanted to mention, guys, the reason that I knew to divide by 1,000 was because it told me here there was 1,000 households. Just to give you a heads up, if they did not tell me how many households there were, what I would do is I would add 125, 428, 256, 108, 83, get my total, and then I would divide each of those numbers by whatever that total was. Okay, so in the event that they didn't tell me it was already 1,000, that's how I would know what to do. Thomas, are we good with that problem there, Thomas? I'm gonna assume that that's it. Yeah, good, awesome, excellent. Emily, you have a question for me?
I do. I need help with number 8.
Number 8. Okay, so let me do number 8, guys, and then I do want to go on to 5.3 because I do think that's an important section. So let me take a look at number 8. Let's see. Here we go. Find it. All right. Okay. Good problem here, and it says a shipment of 10 microwave ovens contains 3 defective units. A restaurant's going to buy 4 of them, okay? And it says, what's the probability of the restaurant buying at least 3 non-defective units? Okay, so let me get my paper again so that I can write this out. And I'm going to show you how we're going to go through this problem. So let me take a look here. We have a total of 10. And out of the 10, there are 3 defective, which means that there are 7 non-defective. And we're going to buy 4 of them. Okay. And we're looking for what's the probability that we have at least 3 non-defective. Okay, so guys, let me show you the process and how I'm going to do this problem. So I'm going to stop sharing this screen with you guys, and I'm going to come back to my dry erase board, okay? And so in doing this problem here, what I'm going to do is, the first thing I'm going to do, I'm going to set up my denominator. In doing these problems, guys, this is going to be a problem where I'm going to be using like my combination button. And it's easier for me to think about doing the bottom part first. So one thing I wanted to mention is we had a total of 10. And out of those 10, 3 of them were defective, which told me that 7 were not defective. And we're looking for the probability of getting at least 3 non-defective, okay? So when I'm putting this x is bigger than or equal to 3, that means at least 3 means 3 or more of them, okay? So think about it this way. When I'm doing my bottom, we're going to say how many microwaves do we have? We have a total of 10, and we're going to buy 4 of them. So my denominator is going to be 10 choose 4, okay? Because we have 10 microwaves, we're buying a total of 4. That's what I'm looking for, okay? Now, my next part, I'm going to do the numerator. So if we want to get at least 3 non-defective, right? So that means that out of the 7 non-defective, I can choose 3 of them. Remember how many microwaves I'm going to have total? I'm going to have a total of 4, right? Then so this part is going to be like this, and then I'm going to multiply that by the 3 that are defective, and I'm going to choose one of those. I want to have a total of 4 microwaves, okay? And then, let me see if I can do this, plus, my second part would be, well, how about out of all the 7 non-defective microwaves, I choose all 4 of those. So then out of the 3 defective, I choose none. And so on my calculator, this is exactly how I'm going to write this part out. Okay. So if you guys can do me a small favor, write that down on your paper or have it down somewhere. And then I'm going to show you on my calculator how I'm going to do this part so that we can see. I'll show you right now, and I'm going to write it down myself. So I have 7 choose 3 times 3 choose 1 plus 7 choose 4 times 3 choose 0 all over 10 choose 4. Okay, so now let me share my calculator with you guys so that we can see how this is going to work. Okay, so let me turn it on and let me get out of here. So second quit, clear, there we go. All right, so on my calculator, guys, I'm going to hit the math button. And I want to get to this PRB part. So one way I can do it is I can hit my right arrow button. See if I can see that. Here we go. I can hit my right arrow button 4 times, or I can hit it once to the left. And now I'm under PRB. And then if you notice, here's my NCR. Okay, that's the feature I'm going to be using. So let me clear this out. The first number I had was 7. So I'm going to type in 7, and then math, PRB. Scroll down. We're going to choose 3 of them, okay, times, then we have 3 choose 1, 3 math, PRB, we're going to choose 1, oops, wrong one, let me go back and get rid of that, let's see, delete it, there we go, math, PRB, there we go, choose 1, okay, and I'll tell you what I'm going to do. I forgot to put some parentheses, so I'm going to insert some parentheses here. So I'll go second insert, parentheses here, and I'll insert them at the end of that one too. Second insert, close off my parentheses right there. Okay, then we're going to go plus. Let me go ahead and put some parentheses again. Now I'm going to have 7 choose 4, so 7 math, PRB, choose 4 times 3 math, PRB, choose 0, and then all of that is being divided by 10 choose 4. So 10 math, PRB, choose 4, and hit enter. Oh, we got a mistake somewhere. What did I? Let me see. Let me try something else. Second parentheses.
Yeah, I think you're missing one up on top where you're times 3.
Yeah, but my 7, if you notice, it's not a parenthesis here. It's like another type of thing. You know what I mean? It's not the parenthesis. Yeah, so let me click. Okay, there we go. Okay, that should do it now. My mistake. And okay, I did something wrong because that's not coming out right. Let's see why. Let me try something real quick, guys. Second entry, and so when I do second entry, it just retypes everything. Let me delete everything here, and I'll tell you what I'm going to try to do. I'm going to try putting, some parentheses here, and parentheses here, and then maybe one more time, parentheses there. Let's see, and maybe one more here, and enter that, okay. And now divide this by, I said 10 math, choose 4. Here we go. And so I'm coming up with 0.666, a whole bunch of 6's right there, right? So let me double check to see if this is going to work. It should. So let me come back to my problem. And it's asking me to round to 3 decimal places. So I'm going to type in 0.667. And let's hit check my answer, and hopefully it comes out. Boom, and there we go. Okay, so guys, I just had to be a little careful with how I entered it in terms of my calculator. But the idea is when I'm doing this problem, just to kind of give you a heads up, when I'm doing this problem here, and let me write this over to the side, so I have a little bit of room, is, let's see. Okay, so when I'm doing a problem like this, the idea is, so we had a total of 10, 3 are defective, 7 are not, and we're going to choose 4, and we're looking for the probability that at least 3 are not defective. I usually work with my denominator to begin with, because I think the denominator is always going to be the easier part. This is going to be my denominator. I have 10 of them. I'm going to choose 4. And then my numerator should be something like, well, look, if I want to pick at least 3 non-defective, so that means out of the 7 that are not defective, I'm going to choose 3 of them. But if I have, out of the 7 that are not defective, if I pick 3 and I need to get a total of 4, that means from these 3 defective, I need to choose at least one of those. And then the other option is, well, what happens if we get all 4 that are not defective? So out of the 7 that are not defective, we choose all 4. So that means out of the 3 that are defective, we don't choose any at all. Okay. And so I want to say, actually, if I were to probably type it like this on my calculator, this would have been okay. And then maybe what I would have done is just type this part first on my calculator. And then once I get an answer, then hit divided by 10 choose 4. But that's really the objective on that type of a problem. Okay. So I'm sorry it was a little messy with it on my calculator, but I'm hoping that at least how I'm setting it up makes some sense. Emily, does that work a little bit?
Yes, it does. Thank you.
Yeah, you're welcome. You're welcome. So let's see. Let me come back over here. Let's see. Second parentheses. Yeah. So guys, I want to go ahead and do a little bit of 5.3 because I know that's what Perla was asking for. Guys, remember on Monday night, I'm going to do a full review. So Monday night, my main goal Monday will be reviewing, so answering any questions out of the review guide. Even if you ask me, you know, I'm happy to even to go over number 11, number 12, or number 8 again. Okay, so we'll definitely go over that stuff Monday. I do want to get a little bit of 5.3 done because I want to make sure that we feel good with this stuff. Like I said, I know that 5.3 and 5.4 were the sections that y'all had to do that were originally going to be due tonight. You at least now know you have a couple extra days, and I did check the website, and it's all good now. Hopefully, it stays that way. Okay. So I was doing this with my other class right before you guys started, and so now I'm going to kind of walk you through the process on doing 5.3. So 5.3 is normal distributions. And so it says in the previous section, we were asked to find the probability. You know what? I don't even know if I hit record. Did I? Yes, we're recording. Okay, good. So it says, sometimes, however, we're given a probability, and instead we need to figure out what is the z-score that leads to that probability. So it's find the z-score that corresponds to a cumulative area of 0.4761. Okay, so what we're looking for is what value of z will give me an area of 0.4761. If I think about my normal curve, the curve that looks kind of like this, right? And in my normal curve, guys, remember the mean is 0, And then my standard deviations are 1, 2, and 3, and -1, and -2, and -3. And I know that the area to the left and from the middle is going to be 0.5 because the area under the whole thing is 1, right? So half of it wouldn't have to be half. And if it's telling me that the area is 0.4761, that's just a little bit less than half, which tells me that the answer that I'm probably going to be looking for is going to be somewhere between 0 and -1. And what we're trying to do is we're trying to figure out what's this z value so that the area this way is 0.4761. So I'm going to show you a couple of ways of going about this. The first way I'm not a huge fan of, but some people do like it, so I'm going to show you. So let me do that real quick, and okay. So I said that the number that I was looking at was probably going to be somewhere between 0 and 1. And the area was 0.4761. So if I look here at my table, I want to make sure you guys can see this. Yeah, you can see this. And if I look right here, look at that number, 0.4761. There it is. So the answer is going to be something like -0.0. And then I got to figure out what's the number when I scroll all the way to the top, 6. So the answer is going to be -0.06. Okay, so this is the first way of going about doing it, right? And you can see that one of the, maybe you might guess, but one of the reasons why I'm not a big fan of doing it that way is, let me see. Is I really have to look at that chart and I have to like hunt for the number, right? And there's a lot of numbers there, and I'm trying to come up with 0.4761, and it's not always so easy. So there's another way I can go about doing that problem, and I'm going to do that using my calculator. So on my calculator, what I'm going to do is, let me do this. And okay, I think you guys can see this now. So let me clear this, and I'm going to go second bars. Okay, I'm going to go right here to where it says inverse norm, and I'm going to click on that one. And the number that we were given was 0.4761. I'm going to put that in there, and then when I hit enter, one thing I want to mention, guys, when I'm finding my z values are always going to be to 2 decimal places. So if you notice it's a negative 0.059, so if I go to 2 decimal places, it's going to give me negative 0.06, right? Which is the same answer that I came up with. And this is just like so much easier, breezier cover girl for me to do, right, than hunting through that table. I would much rather use this because it's just going to be a lot more simple. Okay, so let me get out of this part here, and let me come back to my notes. And I would do the same thing for every one of these problems, right? So when I look at this problem here, the way I'm going to do this on my calculator is I'm going to go to inverse norm, and I'm going to type in 0.05, right? So instead of me pulling the calculator up again, I'm just going to type that here on my own. So I'm going to go second bars, inverse norm, and then 0.05. And let's see, I'm coming up with something like negative 1.64. Okay, so right here, I'm coming up with negative 1.64 as my answer, right? And that's all it's really telling me. Now, I want to make one way you can sort of double check, or how do I really know that I'm coming up with the right answer, is remember, here's my normal curve, right? Here's my 1, my 2, my 3, and -1, and -2, and -3. And I want you to notice the value that we came up with, right? It said the area to the left was going to be 0.05. So if you remember, the area under half the curve is 0.5. So 0.05 is going to be somewhere to the left of 0. And if it's to the left of 0, it's telling me that, you know what, my answer should be negative, right? So at least I'm kind of getting an idea of, should my answer be a positive number or should my answer be a negative number, right? So now when I do part 3, it says find the z-score that has 12.71% of the distribution's area to the right. I want you to think about what that means. That means if I were to draw a picture and it were to look like this, here's my normal curve, right? And here's my 0 and my 1 and my 2 and my 3 and -1 and -2 and -3. 12.71% as a decimal is 0.1271. So that's telling me that somewhere over here, the area here is 0.1271. Now remember, the total area, guys, is going to be equal to 1, right? And because my calculator and my tables always tell me the area to the left, what I really want to do is I want to know, well, what's the area here in this red part? So the way I could find the area in that red part is I could say, well, what's 1 minus 0.1271? So if I do that on my calculator, let me do it here. So 1 minus 0.1271, I'm coming up with a 0.8729, right? And that's telling me that's the area over here. So what I'm going to do now is I'm going to say, let me use my calculator and let me go to inverse norm of 0.8729, and I can find my answer. So if I do that here with you guys so you can see it, let me see. Here. Okay. All right, so I'm going to go second bars, inverse norm of 0.8729, and then hit enter. I'm coming up with 1.14, right? So when I get out of this piece here and I come back to my particular problem, let's see, the number we came up with 1.14. What I can say now is this number that we were looking for here is z equals 1.14, right? And at least I have an idea of what it is I'm trying to do, right? So one thing I really wanted to mention, and I do this, guys, every time I teach these classes, like chapter 5, a big portion of this part here is going to be using your calculator, right? A big part of it's going to be using your calculator. The thing is that how do we know if an answer we come up with is correct or incorrect? And that's kind of what we're trying to figure out here. We're trying to figure out, well, how would I know that that's the right area? Okay, or that's the right answer. So guys, before I go on to number 5, does anybody have any questions that you want to ask me about anything? I mean, am I making any sense as I'm going through this here?
No, I understand. Thank you.
We're good? Okay. I'm just checking with you guys. So look, let me take a look at number 4, and it says, find a z-score for which 75% of the distribution's area lies between z and negative z. Okay, guys, I can emphasize this a whole lot, and I think it's really important that the picture is going to help me so much in doing these problems here, okay? So I'm always going to draw this kind of, laying down picture of the curve, right? And it says we're looking for 2 numbers. One of them is going to be positive and one's going to be negative, okay? Here's 0. This is my negative z, this is my positive z, okay? And we know that the area between this part is 0.75. So now what I want to do is I want to figure out, well, how much would the area here and here be? So remember, the total area is always going to be equal to 1. And if this piece here is 0.75, so if I go 1 minus 0.75, like if I had $1 and I gave you 75 cents, I'm left with 25 cents. But that's 0.25 to be distributed among those 2 pieces. So if I wanted to find the area, say, under this piece, I would take 0.25 and I would divide it by 2, and I'm going to come up with 0.125. So that tells me that the area right here is 0.125, and the area right here is 0.125. Okay? So now, if I want to find what's this number right here, what's that negative z going to be? the way I'm going to do that is I'm going to write out my inverse norm of a 0.125, okay? So guys, I'm going to do this on my calculator here. I'm just going to do it on the calculator I have here in front of me. So second bars, inverse norm, 0.125, and let's see. Okay, so I am coming up with z is equal to a negative 1.15. Okay, so that's telling me this value right here. Okay, now because these graphs are symmetric, then this one is just going to be positive 1.15, and that's all I need to do really for those. Okay. So again, the picture really helps because it just kind of breaks everything down for me. Okay, it really breaks stuff down, and it helps me figure out, you know, what kind of answer should I be coming up with and that kind of thing. And as long as I remember stuff like the area, the total area is 1, then I can find some of these missing pieces. All right. So let me go to number 5, and we'll do it the same way. And so it says find the z-score that corresponds to each percentile. So all this really here, guys, is telling me is I'm going to draw my normal curve. It's going to look like this. Here's my 0. And it's telling me that the area over here, since this is a percentile, I have to think about that as like 8%. And as a decimal, that's going to be 0.08. So again, all I'm really going to do here, y'all, is I'm going to go inverse norm of 0.08, and then that's going to give me my value for z. So if I go second bars, inverse norm of 0.08, and I'm coming up with something like negative 1.41, because I'm always going to go 2 decimal places, guys, on my z values, right? And then I would do the same thing for this one and this one. I would do inverse norm of 0.25 and inverse norm of 0.95. Okay. So let me kind of jump down to the next piece here, and I'll explain this part for you guys. And let's see what it says here. It says transforming a z-score to an x value. It says just transformed x values in a non-standard normal curve to z-scores on the standard normal curve. We can transform z-scores from the standard normal curve to x values on the non-standard normal curve. So it gives me a formula right here, okay? And I'm going to show you how I'm going to work this formula. So it says, number 6 says, a veterinarian records the weights of dogs treated at a clinic. The weights are normally distributed with a mean of 52 pounds and a standard deviation of 15 pounds. Find the weights x corresponding to z-scores of negative 2.33, 3.10, and 0. Okay, so let me draw my picture. Here's my picture. Here's my normal curve. Here's 0, right? And then here's my 1, my 2, and my 3. And my negative 1, my negative 2, and my negative 3. And in this particular problem, we know that the mean is 52 pounds. So that's telling me that my mu is 52. Okay, that's going to be the number in the middle. And then my standard deviation sigma is equal to 15 pounds. And now it says find the weights x corresponding to these different z-scores. Okay, so we're going to find, I'm going to call it x1 because it's for the first one. So the formula is mu plus z times sigma. Okay. So my mu I already know is 52. My z-score in this case is a negative 2.33 times my sigma, which is 15. Okay. And I'm just going to do this on my calculator, guys, and I'm going to type this in right here. exactly as I see it, okay? So just to give you a heads up, let me show you what I mean by this. So let me go here, and let's see, okay. I'm gonna clear this business out. And so we had the number 52 plus, and then I had a negative 2.33 times 15. That's how we wrote it out. And I'm gonna hit enter, and I'm coming up with 17.05, okay? So there's my first value. So let me stop sharing this business here, and let me come back to my page. And we came up with 17.05. So guys, I want you to think about this for a second. Look what it told me here. It said that the average weight of these dogs was 52 pounds. Was this particular dog above the average or below the average? Anyone know? What do you think? Something in the chat, so let me take a look. And so, okay, so guys, look at, hold on, take a look. Look at what the average is. The average is 52, right? Sorry, the average is 52, right? This dog weighs, that's 52 pounds. This dog weighs 17.05. Would you say that dog is above average or below? That's right, it's below, right? It's actually below. Okay, so I want you to think about something. Because this dog's weight is below the average, okay? Since it's below the average, remember what the z-value for it was? The z-value was a negative 2.33. It was over here. Remember, this is my average. And because this dog has a z-value of negative 2.33, that's just telling me that this dog is underweight, right? Or it weighs less than the average weight of all the dogs, right? So maybe, you have a whole bunch of dogs at this clinic. Maybe there's 100 dogs, and some dogs are bigger and some dogs are smaller. So maybe you have, like a mid-sized dog or a smaller dog that only weighs 17 pounds, and then you have other dogs that weigh more. So this dog weighs less than the average weight. Okay. Now I'm going to do the same thing again, and I'm going to now use 3.10. Okay, so I want you to think about what 3.10 would be. 3.10 would be all the way over there, right? So when I find that z-value, and remember the z-value is written like this, and I'm sorry, we're looking for the x value, not the z-value. Sorry, because we're trying to find the weight of the dog. We're going to take 52 plus z, which is 3.10 times my standard deviation. And again, guys, I'm going to type that in exactly as I would see it. So let me get my calculator here. I'm going to type in 52 plus parentheses 3.10 times 15. And the number that I'm coming up with is 98.5 pounds, right? So this dog obviously weighs more than the average, right? And again, how do I know that? Because his z-value is a positive number. So if the z-value has a negative number, that means the dog is less than the average. And if a z-value is a positive number, that means that the weight is more than the average. And then I want you to look at the last one. The last one says, we're going to do this again, but now when the z-score happens to be 0. So if I say, look, x is equal to mu plus z times sigma, okay, and this is 52 plus my z-value of 0 times 15, I'm going to come up with 52. That's where that z-value of 0 is. This dog weighs exactly the same as the average because that dog has a z-value of 0, right? Okay, so let's see if we can do the same type of thing here in this problem. And it says, in a survey of men ages 20 to 29 in the United States, it says the mean height was 69.4 inches with a standard deviation of 2.9. And it says what height represents the 90th percentile. Okay, so first thing I'm going to do here, I'm going to draw my standard normal curve. Okay, so here's my curve. Here's my 0, 1, 2, 3, -1, -2, -3. So the first thing I need to do is if I'm looking for the height that represents the 90th percentile, what that's telling me is I want to know what is the z-value right here so that the area under that curve is 0.90. So in order for me to do that, I have to figure out what is that z-value. And the way I can do that, y'all, is I can go inverse norm of 0.90. Okay. So take my calculator, and I'm going to go second in bars. I'm going to scroll down to inverse norm, and I'm going to type in 0.90. And I am coming up with a number of z is equal to 1.28. Okay. So now I found my z-value. Okay, I found my z-value. In this particular problem that we have for number 7, we know that our mu, our average, is 69.4. With the standard deviation, my sigma is equal to 2.9. What I want to do is I want to find what is the actual height in inches that represents that 90th percentile. So the way I'm going to do that is I'm going to say, well, the formula is x equals mu plus z times sigma. So x is equal to 69.4 plus z, which in my case was the 1.28, times sigma, which is 2.9. And I'm going to type this right here, guys, exactly as I see it on my calculator. So let me stop sharing this here, and let me come back to my calculator so we can see what I'm trying to show you. And let me turn it on. Okay. And so what I'm going to type in is I'm going to type in 69.4 plus, and then I'm going to put parentheses, 1.28 times 2.9. And then I'm going to hit enter. And I'm coming up with 73.112, right? So my answer for that part will be 73.112. So let me come back one more time. And here we go. So for part A, the answer I came up with was 73.112. And this is in inches, right? Okay, part B is going to be almost identical. Part B, here's my curve, right? It's a little messy, but there's my curve. The first quartile, I want you to think about the word quartile. Think about quarters, right? Quarters is 25 cents, right? And 25 cents is 0.25. So if I know the area here is 0.25, what I want to do, y'all, is I want to find that z-value. So the way I'm going to go ahead and do that is I'm going to go inverse norm of 0.25. So if I take my calculator, let me see, inverse norm and 0.25. Okay, the answer that I came up with was z was a negative negative 0.67. Okay, so here's my z-value. All I'm going to do is the same thing that I did earlier with this piece right here. So I'm kind of running out of room. Let me write it over here where I got some room. My z was a negative 0.67. Okay, let's find our x value. So mu plus z times sigma, 69.4 plus my z value times 2.9. And again, I'll just do this on my calculator here, but that's exactly how I'm going to type it in. 69.4 plus parentheses negative 0.67 times 2.9, close it off, and I'm coming up with something like 67.457. So for part B, I came up with an X value, write it in green, X value of 67.457, and this is again in inches, right? All right, so I'm hoping that some of this stuff here, guys, makes a little bit of sense. I want to, I don't know if I'll have to do both 8 and 9, but let me at least do part 8, because I think we can get through number 8, and I'll let you guys do number 9 on your own, or you can always go and watch the video. But I'm hoping that me going through this section is kind of making some sense. At any point in time, guys, if y'all have questions, please don't. You don't have to wait for me to stop talking, because chances are I won't. I'll keep talking here. So at any point in time, if y'all got a question, please let me know. I'm happy to help you guys, okay? And you're not going to offend me by saying, sir, can you go over that again, or can you stop? And I didn't understand this part. So let me at least set up problem number 8 for you guys so we can see if we can figure this thing out. And number 8 says, scores on an exam for an entry-level position at a reputable firm are normally distributed with a mean of 50 and a standard deviation of 10. So right there, that tells me that, okay, that tells me that my mean is 50 and my standard deviation is equal to 10. And it says the firm will only hire applicants with scores in the top 10%. Okay, so I want to think about that for a second. Here's my curve, right? And it says, in order for you to be considered, you have to score in the top 10%, right? That means that your score needs to be right there, somewhere in that area. So if this area in the red is 0.10%, would you all agree with me that this area would be 0.90? Because the whole thing has to add up to 1. So if I know the part in the red is 0.10, then the part in the other part has to be 0.90, because that adds up to 1. And then what I want to do is I want to find what is that magic z value, right? What's that magic z value going to be? And the way I'll find it is I'm going to go inverse norm. Now, guys, remember, when I'm doing this on my calculator, the number that goes in here is going to be my area, but it's always going to be my area to the left in my graph. And so when I mean to the left in my graph is I mean that it's going to be this area here. That's just how my calculator or my table works. It always tells my area to the left. So I'm going to have to go inverse norm of 0.90. So let me do that real quick, like second bars, inverse norm, 0.90, and I'm coming up with 1.28. Okay. So that's telling me that my z value here, I'll tell you what, I'll just write it right here, is a 1.28. Okay. And now it says, what's the lowest score an applicant can earn and still be hired by the firm? So what I'm trying to do is I'm trying to find what is my x value going to be. So remember, the formula is x is equal to mu plus z times sigma. So my mu in this case was a 50. My z value that I came up with was a 1.28, and my sigma here, was a 10. And then this is exactly how I'm going to type it in on the calculator. And I'll write that 50 plus parentheses 1.28 times 10. And I'm coming up with something like 62.8. Okay. And based on the way this score or this testing works, that's the lowest that I can make on my test and still be considered for the higher, right? Okay. And anyway, guys, number 9 is going to be a very similar type of problem. Okay. but this is just how I was kind of setting these things up for you guys. So I hope this was helpful. Perla, I know you were asking me about 5.3, so we did almost all of it. There was just one problem that we didn't get a chance to go over. But again, guys, in the videos that I made for you guys, you know, all these problems are there. Excellent. Good, 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 good. So, guys, just a heads up. Remember, Monday, my main focus on Monday is to answer any questions on the review. So between now and Monday, you know, try to work as much of that review as you can. The school is officially closed Thursday through Sunday for, they call it the semester break, which coincides with Easter. We're still open tomorrow, guys. So tomorrow, throughout the day, if you have questions, message me on Pronto or Remind. I'll make videos. I'll send them out. I might have some time on Thursday, even though we're officially closed. But if you send me a message on Thursday, there's a good chance that I'll probably be able to get back to you. The weekend is probably going to be a little rough. I don't know if I'll get a chance or not. But you know, if you have a question, message me. Right? If I don't get back to you over the weekend, Monday morning, I'll message you. Okay. So anyway, I hope y'all found this helpful. I'm glad y'all were able to show up. Any point in time, guys, if y'all have questions, let me know. You know, my main goal is to help you get through this stuff here. And I hope you guys are doing well. I hope you guys are staying safe. I hope you all have had opportunities to get vaccinated. I'm really happy, guys, because I got my second dose right before spring break. And so today, for the first time, I went and got a haircut. There wasn't like a home style. And so, you know, trying to regain a little bit of normalcy, or what we consider to be normal, but I'm still being as safe as I can, right? I haven't eaten inside a restaurant since before all this started, and I'm perfectly okay with that. But anyway, I hope, thank you. I hope you guys get a chance to get vaccinated, guys. And in the meantime, just be really careful, okay? I want you guys to be safe. I want you guys to be healthy, and I want your families to be safe and healthy, okay? Anyway, I'll go ahead and sign.
Professor.
Oh, you're welcome, guys. You're welcome. I was happy to be here. Happy to help you guys out. Let's see.